Hello all, I am Shifa Salah and I am a student of Government Engineering College, Idiki. Today I am going to take a topic on Direct Memory Access DMA. And now when we are hearing about this DMA, there in our mind some of the doubts came or some of the questions came. How do the data from the computer get transferred to the peripheral devices, or how do the data from the computer get passed to a pen drive? Here are some figures, that is some peripherals like a pen drive is connected to the system, and there are some peripherals also seen. Okay, that's I am marking here. There are some peripherals, and now let's have a look. So basically DMA takes over the entire data transfer function. What is this DMA stands for? This DMA stands for direct memory access. And here from the name itself we can think about it as what is DMA. DMA is direct memory access, and there is a direct memory accessing between the input and the memory. There is no involvement of CPU. And why without CPU? It is just to speed up the operation. And what it means, direct memory access. Now, while studying about something, we want to know about what it is for, or without them what is the demerits. So, whenever we want to access memory from this input output to CPU and from CPU to memory, so here from accessing an information or data transferring from an input output devices to the CPU, we need one cycle, that is here already seen, and from CPU to this memory we need the second cycle. So two cycle is needed to perform this operation. So the process become complex and time consuming. So if there is a direct connection between these input output devices and the memory like this, we only need one cycle. Okay. So it is a merit. So for directly accessing the memory from input output device to the memory, or from memory to input devices, there is only one cycle needed, and for this we want to use a DMA. So if there is a direct connection between memory and input output devices, so entire process can be completed in one cycle. Here, to provide this functional DMA is introduced for providing this direct connection, or for this data transfer. Here we use DMA. So connection between input output to memory through DMA controller or DMAC. This controls the entire process. So here this input output devices is connected to the memory through this DMAC, and this is known as direct memory access. Now we want to look at what is DMA, or summarizing those points we are discussed in the previous slide. What is DMA? Direct memory access is a bus operation that allows read and write between I/O devices and memory not controlled by CPU. This DMA transfer is controlled by a DMA controller, which requests control of the bus from the CPU. After gaining control, the DMA controller performs read and write operation directly between devices and memory, and the figure of this DMA controller is showing in the next slide. Now let's see here when RAM needs data from RAM. Here this RAM is the memory. data from this IO devices. Here is this IO devices, and here the IO devices is hard drive, and the CPU signal a DMA request. The CPU will give a DMA request to this DMA controller, and along with transfer size, destination address and other important information, the DMA controller transfer data while the system bus is free. It generates RAM address itself. A CPU interrupt is generated once the transfer is done, and the result is the CPU is free to do other things. Okay, now let's look at this. The DMA requires the CPU to provide two additional bus signal. What are they? Bus request is bus request and bus grant, and bus request is an input to the CPU through which DMA controller asks for ownership of the bus, and the bus grant signal that the bus has been granted to the DMA controller. And the CPU controls the DMA operation through registers in the DMA controller. So the DMA controller has three registers: starting address register, length register and status register. The starting address register specify where the transfer is to begin, and this length register specify the number of words to be transferred, and the status register allows the DMA control to be operated by CPU. So here is a figure of DMA process, and the steps are also given in this figure, and another slide here the detailed step of direct memory access is given. Let's have a look at the figure. And the CPU will send the register of DMA. So basically the program starts by DMA controller by sending its register. Here is the DMA controller. It has three registers. We already seen in the previous slide, and there is an address, count and control registers here registers, and by sending these registers the process will start. Then CPU will tells the disk controller, this CPU. Here we can see the second step, and this is by connecting. CPU will tells the disk controller, this disk controller and the CPU. There is a communication, and CPU will tells the disk controller to read the data from the drive and store it in the buffer. Okay, here we can see the buffer. This buffer is a temporary storage. So why? Because DMA cannot perform until there is data in internal buffer. Then DMA control will request disk controller. This DMA control will request the disk controller. This DMA will request to disk controller for to transfer the data to the memory. For transferring the data to the memory, the DMA controller will request the disk controller, and so in next step the disk controller will transfer the data to the memory. Here we can see the disk controller is transferring the data to the memory, and after the transfer of data, disk controller will send an acknowledgement to the DMA controller, and we can see that acknowledgement that disk controller is given to the DMAC, or direct memory access controller, and after getting the acknowledgement it will decrease the count. Okay, the count will decreases. Then it will check whether the byte count is equal to 0. Here we can see this is equal to 0 or not equal to 0, and when it is not equal to 0, these steps like this step and this third and fourth, this acknowledgement, data transfer, all will happen in second way, or happen or repeats again. And if the byte count is equal to 0, it will send an interrupt. Here we can see that interrupt. Okay, this byte count is equal to 0, this will send an interrupt and seeing that the transfer has happened, and we can see here that the transfer is complete. And what is the role of DMAC? Or DMAC will help input output and memory has direct access, and it is without the involvement of CPU, so they are saving the cycle and saving the time. So the demerits has been solved by replacing or by using DMAC. Here most important is we are seeing four blocks like a CPU, DMAC, disk controller and memory, and is connected to a bus. And now this is important, and this figure we can see four blocks, and the transferring data is happening through DMAC. So we can see the detailed step here. Step 1, the CPU will send the register of DMA. So basically the program starts by DMA controller by sending its register. Then CPU will tell the disk controller to read the data from the drive and store it in the internal buffer. Buffer is temporary storage that we have already seen. The data is stored in the internal buffer because DMAC cannot perform until there is data in internal buffer. Then step 2 is DMA controller will request. Requesting is the second step. Disk controller to transfer data of the memory. Then we can see in the third step there is a transfer of data to the memory, and the disk controller is transferring the data. And in the step 4, after the transfer of data by disk controller, then it will send an acknowledgement to the DMA controller, and after getting the acknowledgement, this acknowledgement is important, and this will decreases the count. Then it will check whether the byte is equal to 0 or not equal to 0, and if it is equal to 0, then it will send an interrupt saying that the transfer has happened. And if it is not equal to 0, these four steps, which one? Step 1, step 2, step 3 and step 4 will repeat. Okay. Now, by concluding the DMA process, here is some points like the bus request is asserted by the DMA controller when it wants to control the bus. The CPU will finish all pending bus transactions before granting control of the bus to the DMA controller. The bus grant is asserted by the CPU when the bus is ready, and the CPU initiate a DMA transfer. The CPU is initiating that we have already seen in the previous slide by setting the starting address and length register appropriately. Upon becoming bus master, the DMA controller has controlled all bus signals, and once the DMA controller is bus master, it can perform read and write using the same bus protocol as with any CPU driven bus transaction. And after the transaction is finished, the DMA controller returns the bus to the CPU by deasserting the bus request, causing the CPU to deassert the bus grant. That is what DMA process. Just about DMA process, and this figure and process is an important one. 4 steps, and the byte count is also important if it is 0 and if it is not equal to 0, and the process by requesting and data transferring acknowledgement by completing it through the interrupt transfer. These all are important steps for DMA process, and that's all from my side, and thank you for listening. Okay, that's all. Thank you.